Hi, and welcome to our video notes, the first part of our video notes for Lesson 11.4. There's going to be a lot of new terminology we cover here, so I'm going to try and kind of go through it pretty quickly, but we'll see how much we can get through, and we'll finish the rest in class. Okay, we're going to talk about the area of regular polygons today. A regular polygon, remember, is a polygon where all sides are congruent, and so we've looked at areas of regular quadrilaterals, those are just squares. And we can do area of a regular triangle also because we know the area formula for triangles. But now we're going to look at lots of different polygons like hexagons, octagons, things like that, pentagons as you'll see here, where we can use this formula to find the area of any regular polygon. And there's some things that are important to understand here. This lowercase a represents what is known as the apothem. We call it the apothem, not apothem, apothem. And then P is the perimeter of the figure. Just the length of all the sides added up. But remember, all the sides are the same length, so if you know the length of one side, you just multiply by how many sides there are to get perimeter. The apothem is this measurement here. This is our new measurement. It's the distance from the center of the polygon to a side where it's perpendicular to the side. So the line from the center of a regular polygon perpendicular to a side is called the apothem. And that measurement will be used quite a bit. Now before we get going too much further, we want to look at a reminder about special right triangles. In a 45-45-90, the leg length times square root of 2 is what gives you that hypotenuse length. And in a 30-60-90, the short leg times 2 is the hypotenuse, but the short leg times square root of 3 is the long leg. And that's going to be really important for us to remember as we go about doing these examples. Okay, so our first example, they go ahead and give us most of the information. This one won't be very difficult. It's pretty straightforward. They tell you that we have a top of a table shown. The table is a regular hexagon with a side length of 3 feet and the apothem of 1.7 feet. So they just give us the apothem now. And so it's not hard to do. Remember your area formula. Area equals 1/2 apothem times perimeter. And so we need to know that perimeter first. So we're going to find the perimeter by taking that side length of 3 feet times the number of sides that there are. It's a hexagon, so there are 6 of those sides. 3 times 6 is 18. So we have a perimeter of 18 feet. So we can plug that in for P, and they give us the apothem of 1.7. So we can just take and plug into our formula. 1/2 of 1.7 times 18, and then we plug that into the calculator, and we should get 15.3 square feet rounded to the nearest tenth. All right, and that leads us to example 2. In example 2, we're going to do the same thing. We've got hexagons again, but we do it a little bit differently because we are not given what the apothem is. We have to calculate that first. That's one piece that we have to find first. But because of the way these shapes work out, we can find that using either special right triangles or trigonometry, and I'll show you how we can figure that out. We know the side length of this hexagon is 5, so I can already find the perimeter. Remember, that's one thing we're going to need is the perimeter. Side length is 5 times 6, because there are 6 of these 5-meter sides, which is 30. So I know the perimeter. But in order to find this apothem, I want you to look at how the apothem drawn in with this triangle gives us a right triangle, where the short leg, excuse me while I drop the pen, the short leg is 1/2 of 5, okay, because it intersects at the middle. The apothem will always bisect one of those sides in a regular figure. But this longer leg is going to be related to that if I know what these angles are. I either have to know the angle measure and use trigonometry, SOHCAHTOA, or I might have a special right triangle if I can find those angles. But I want you to look back up here at this picture. All right, these angles formed at the center are called central angles. There are 1, 2, 3, 4, 5, 6 of these central angles around the center that are all congruent, Well, if I were to start at this point and go all the way around, I'd be going in a circle 360 degrees. So to find the central angle, we take 360 and divide by the number of sides, or in this case, 360 divided by 6, which gives me 60 degrees. So a central angle is 60 degrees, and then this angle in the yellow right triangle that I've used is half of 60 degrees. So in that case, 30 degrees. So that makes that a 30-degree angle, and I'm going to redraw that triangle over here. That's a 30-degree angle, and that's a 60-degree angle. We do have a special right triangle that's 30, 60, 90. This is our short leg of 5 over 2, I'm sorry. 5 over 2 is really just 2.5. It's easier to look at that as a decimal. And so to be able to find the apothem, which is this long leg of that triangle, we can use our special right triangle lengths. If you go back to this, our reminder here, the short leg times square root of 3 is what gives us that long leg. So the apothem is 2.5 times the square root of 3. And we can just write it as a decimal form because that's what we're going to use in a calculation. So that's our apothem, and this was our perimeter. So we can plug into our area formula now. Remember, our apothem was 2.5 square root of 3. Our perimeter was 30, and then half of that means I can divide it all by 2. And so we just plug it into the calculator. I recommend doing this part first and hitting equals, then times 30, then divided by 2. In that order, it's going to help you out a lot. So if we do 2.5 times root 3 times 30, all divided by 2, we get an area that is approximately 65.0 square meters, because it's 64.99, and so we have to round that up, or it might be 64.95, I believe, I'm sorry. But when we round to the nearest tenth, then that rounds up, and we get that answer. Okay? All right, we're going to do another example like this, part B. We're going to do that example in class. For the sake of time in the video, I want to go ahead and move on to the next examples when they're not hexagons. When we don't have hexagons, we won't be able to use a 30, 60, 90 because this angle won't be 60 degrees and that one won't be 30 if it's not a hexagon. Because when we change the number of sides, the central angle changes, and so we'll get a different angle measure like you'll see in the next problem or two. So in example 3, we have a pentagon. And in a pentagon, there are 5 sides. So the first thing you want to do is write your formula down. And know that we need to find the perimeter and apothem to be able to find that. The only measurement they give us here is this length. Now, that is the hypotenuse of this right triangle. I'll highlight it again for you. Okay, we're using that right triangle again, and I'll come down here and I'll draw it. Where this is 9, that's our hypotenuse, but I don't know either of these parts. I need to know these parts. I'm going to call one of them x, and this, instead of calling it y, I'm going to call it a for apothem. Now the apothem is this longer leg, x is the shorter leg, but again, we cannot use special right triangles here. We have to use some other method. So what I'm going to start by doing is finding that angle measure, which is half of a central angle. So first I'm going to find our central angle measure. Remember how to take a central angle measure? We take 360 divided by the number of sides, in this case 5. And if I do 360 divided by 5, okay, that is 72 degrees. And this would be half of that because there's one here and one here. So if that angle is 72, half of that is 36 degrees. So that's not a special right triangle, but we can use trigonometry. Okay, we can use SOHCAHTOA to figure out which sine ratio, cosine ratio, or tangent ratio we should use. Now, I don't care which one we decide we want to find first. You can find the apothem first or this side first. It's up to you. I'm going to choose to find x first so that I can say if this is x and this is x, I can double that to find my side length to find my perimeter. I need to know both of these to add them together or multiply by 2, and then I would multiply by 5 to get my perimeter. And so I'm going to find x first. X is the opposite leg from that angle, and 9 is the hypotenuse. So I'm going to use sine. I'm going to say sine of 36 equals x over the hypotenuse 9. And if we make that a proportion, we cross and multiply, x would equal 9 sine of 36. So I'm going to do that calculation. When I do that calculation in my calculator, it comes out to be about 5.3. It's a little bit longer decimal, okay, but it's about 5.3, and so I need to double that to about 10.6. And then when I multiply that by 5, I actually get about 52.9 whenever those values actually work out a little bit differently. We get 52.9